Hi class, this is Mr. Amy, and today we're going over our Module 4 study guide. Stick around and pay close attention for the secret word. Remember to write it down somewhere on your study guide, and you'll get a special treat on the day of the test. Alright, so number 1 says, use the diagram below on the right to answer the following questions. Well, here's our diagram below to the right. And the first one says, name an acute angle. Well, the first thing I need to know is what is an acute angle. Now I remember that an acute angle is smaller or less than a right angle. Well, what's a right angle? Fold any piece of paper twice in both directions, such as this circle, but it could be any shape. Fold it once, fold it twice, and you've got a right angle right here. 4 right angles together make a complete circle. And this is our benchmark angle, which means the angle we're going to compare others to decide. So as I said, acute angles are smaller than right angles, or less than right angles. So what I would do is I would move around this diagram and fit this right angle template into different angles I see in this figure and compare them. Well, that's lining up with this side and this side, so that's clearly an equivalent angle, so that's also a right angle. So is that one. And remember, I can rotate this any way that I want. I'll rotate it this way to fit into this angle. And I'm already seeing this angle here would continue this way, so it is less than this right angle. It doesn't go up far enough to be equal to this right angle. So right here is my acute angle example. And I'll just mark this here. Just to remember, this isn't required. That's not a very good marker. Let's try another one. But for the study guide, I'll go ahead and mark these as my angles, or my angle that is acute. Now remember, it takes 3 points to make an angle. So I'm going to write my angle symbol as I name this angle. And then I'm going to name the 3 points in the order that I see them. A, D, B. So that angle's name is angle ADB. Part B says, name a right angle. Well, I happen to have found one when I was looking earlier, didn't I? Right here. Angle EFH. I'll mark that one so we can see it. That is a right angle. So I put my angle symbol, and then an E, and an F, and an H. I meant to mention this earlier on number 1, but these answers are not the only answers. There are possibly other acute angles and right angles in this figure, so there could be multiple right answers. For example, I could just pick one out here. Acute angles, well, here's another one right here. So I could have said angle DGC, or even AGC is acute. Or another right angle, as I mentioned earlier, was right here. I could have said EGI, or even FGI. So there's multiple correct answers that I'll accept on this test. Part C says name an obtuse angle. Well, I know that an obtuse angle is greater than a right angle. So I'm going to move this around, see if I can find 2 lines that intersect and have a greater space between them than this right angle template. So far, nope, nope. Well, look at that. Angle ADF is much wider than this right angle template. And since we've already used yellow here, I'll use another color. There's an angle right there. Angle ADF is an obtuse angle. So my angle symbol, then ADF. While we're talking about multiple answers, it would have also been fine to say FDA. You can go either direction, just like my ADB could have been BDA. The key there, though, is that we're tracing the path. I could not have started with D and then gone to A and then gone to F, because that would be identifying something different. All right, name a line segment. Well, I remember that a line segment is connecting of two endpoints. So I'm just going to find literally any two endpoints in this figure can be used to create a line segment. I'll just pick a simple one right here. Points G and F are connected to make a line segment, or even FG. I'll just go top to bottom. So point F and point G, and then I put a little line segment on top to signify that it's a line segment. Now I'm looking for a ray. Well, I know the difference between a line segment and a ray is a line segment has two endpoints. A ray has one endpoint, and then it goes on forever the other direction. And again, we have multiple examples of that here. Anywhere where there's a point that ends in an arrow, like that, GI is a ray. Well, so is FH, so is FE, DB, DA. There's tons. But for now, I'll say GI. So I'll name the points G and I, and then I'll put a little ray on top to indicate I'm talking about the ray GI. These symbols are very important, and I'll be looking for those on the test. As you're seeing here, because there's so many correct answers, you've got to be very specific with your symbols so that I know that you're looking and thinking about the same thing that I am. All right, so name parallel lines. Well, I know that two lines are parallel if they are a constant distance apart. They will never get any closer together, no matter how far they go on. So, one way to measure parallel lines is to take your right angle template and put it parallel with a line, such as this one here. We could call that line BH or FH. And then I'll put my ruler on there, on the other flat edge, and then I'm going to slide my right angle template down, and you can see it matches perfectly with the line underneath, line CI or GI. That tells me that these two lines are parallel. So I'll name the points B and H, and I'll put the line symbol over it, which is two arrows, signifying that it goes on forever both directions. And then I'll put the parallel symbol, which is two little vertical parallel lines. And then I'll name the second line, CI, and put my little line with the arrows going both ways on top. So this says line BH is parallel to line CI. All right, lastly is perpendicular lines. Well, two lines that are always a constant distance apart, will never touch or intersect, are parallel. Perpendicular lines do intersect, and they intersect in a particular way. Two lines are perpendicular if they intersect to form a right angle, and I happen to have a right angle right here. So, line EF and line FH are perpendicular lines. So, and I could say line, I could say line segment, I could say ray. I'll say ray. FE is perpendicular to, so we put just a little pair of perpendicular lines as the symbol, ray FH. FH, and put a little ray on top like that. That's how you do it. Now, as I said before, there's multiple answers here. You notice here I didn't use lines, I used rays, and that's okay for this particular problem, unless it asks for a ray, like part E did here, or you want to do something more specific. but I'll be flexible there as long as you show me that you're able to identify those different figures. All right, let's look at number 2. Classify the angles below as acute, right, or obtuse. Explain how you know each angle's classification. You may use a right angle template to help you. Well, we kind of already went over this, didn't we? I'm going to use my right angle template. I can see this angle is too small. So I would say acute, because it's less than a right angle. And this one here, I would say is obtuse, because it's greater than my right angle template. All right, now let's look at the last one here. Number 3 says, find and draw all lines of symmetry in the following figures. If there are none, write none. If there are an infinite number, write infinite. Well, if I look here, I know these little notches on the edges tell me these 3 lines are equal length. Whoops. Let me get the lights on. There we go. These tell me they're equal length, so I know that this is an equilateral triangle. Little preview for the next page. And I also know then that these 3 angles have to be equal as well. So I have 3 equal sides and equal angles, and I know the more I have that's equal, the more likely I'm going to have balance to this figure, which means I'm going to have more lines of symmetry. Just to review, symmetry, a line of symmetry is a place where you could fold this shape and one half would completely cover the other, where the edges would line up perfectly. So I could take my straight edge and I could draw a line going vertically, and I know that if I folded this along that line, this side and this side would match perfectly. Well, however, I could also do this. I could just rotate my triangle, and because it's equilateral, it looks the same. So again, I could take my ruler, draw that line, and I know this side and this side would be the same. And once again, I could rotate it and do the same thing. Now I can only do it 3 times because all 3 sides are equal. If they weren't, then that would reduce the number of lines of symmetry that there would be, but since it is an equilateral triangle, there's 3 lines of symmetry. Now circles are special. Now you notice I did a lot of rotating here, and I said the word balance. If you think about a circle, you can pretty much chop it in half any way. I could rotate this all day. Oh, that's not a good one. I could just keep rotating and rotating and put line upon line upon line, and every one of these would be cutting it in half. There's no end to how many times I could break this in half. So this one is the only figure that has an infinite number of lines of symmetry. This one, on the other hand, if I think about where I could fold this, where all the edges would line up and one side would completely cover the other, it's impossible. The closest I could come is maybe I could fold it right here. If I folded it right here, this side would flip over onto this side, but this side would need an arrow, or this side we'd need to cut off that arrow, so that's not going to work. There's no way to fold that where the sides will match, so this one has no lines of symmetry. All right, let's head to the back side. Classify. Oh my goodness, I wrote classify twice. Well, good thing this is not English, huh? Classify each triangle by its side, length, and angle measurements. Circle the correct names. You know what? I think I just thought of our code word. Classify. Write that on your paper and get a special treat. Okay, so here we go. Classify each triangle by its side length and angle measurements. Circle the correct names. Well, when we're classifying side lengths, we have three names: equilateral, isosceles, and scalene. To be able to classify these, I need to know what these words mean. Equilateral means three equal sides. It's right in the name. Equilateral is three equal sides. An isosceles is two equal sides. I've mentioned this before, but I always think of isosceles. There's eyes. I have two eyes. This triangle has two equal sides, so two. And then the last one, scalene, means no equal sides. Now that I've reviewed what those terms mean, I can decide, looking at this triangle. Now, thankfully, someone did the work of measuring these for me. I can tell because of these notches. I don't really care what these measure. I just care about how they compare with one another. And these notches tell me that these two sides are equal. This one doesn't have a notch, so I know it's not equal. Plus, I can just look at it and see that it's longer. Since there's two equal sides, it's isosceles. I'm just going to go ahead and go down the column on this while these terms are fresh in my mind. Here I have three notches, so I know all three are equal. And as we saw in the triangle on the front page, that means it's an equilateral triangle. This one, I have no notches, and I can kind of tell this one is a small line, a medium line, and a long line. They're all different, so that's a scalene triangle. Finally, again, no notches, small, medium, large, scalene triangle. All right, the second thing we can look at in classifying is by the angle measurements, or the size of the angles. And here I can use my right angle template again. Now, I know that triangles have to be made using at least two acute angles. It's just not possible without at least two acute angles. So it's really that third magic angle that we look at to decide how we're going to classify it that might be different. When I look at this one, we can zoom in a little bit more. This is clearly an acute angle, too small for me to fit my right angle template in there. Same with this one, too small for me to fit my template in there. This one, however, is too big. That's the magic angle. It's an obtuse angle. So, this is an obtuse triangle. I'll move a little quicker on these next ones. That's an acute angle because my right angle template doesn't fit in there. Same with that one. Same with that one. Since all of them are acute, it's an acute triangle. And this one, oh boy, look at that. They labeled it for me. I know that box means it's a right angle, but just to prove it, I can put it in there and you can see that right angle template fits perfectly in there. So this is a right triangle. And then lastly, this little angle, too small. This one, too small. This one is bigger. It's greater than my right angle template, and I know greater than right angle is obtuse. All right. Almost there, guys. We're on the home stretch. Thanks for sticking with me. Let's move on to part 5. Use the word bank to name each shape. Be as specific as possible. And that's important because we know that I could say quadrilateral, 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 and quadrilateral, and I'd be right because they're all four-sided figures. But they're different too. And what makes them different is what gives them their unique names. This first one, I see I've got one pair of parallel lines, two lines that are not parallel, but are of equal length. And I know that a quadrilateral that only has one pair of parallel lines, or at least one pair of parallel lines, is a trapezoid. By the way, I forgot to mention, these little arrow symbols are telling you that these two lines are parallel, so you don't have to measure them yourself. The next one, I have one pair of parallel lines, one arrow, and then I have two sides with two arrows telling me that these two are parallel with one another too. So these two are parallel, and these two are parallel, two pairs of parallel lines. That's a lot of parallel going on. So clearly it's a parallelogram. So once again, quadrilateral means four sides. If it's quadrilateral with one pair of parallel sides, it's a trapezoid. If it has two pairs, then it's a parallelogram. Next we have four equal sides, which I know because of these tick marks that tell me they're equal. And it's not indicating anything about the angles, but I can use my right angle template and tell that they are indeed all right angles. So a figure with four equal sides and four right angles is a square. And last but not least, we have a figure here with four right angles and two pairs of parallel. They're not marked that way. We could infer, or we could even prove it by using a right angle template slide method and see that they're parallel because they keep lining up. Do the same on this side. So two pairs of parallel lines and four right angles, that's a rectangle. All right, there you have it. Thanks for sticking with me, guys. Good luck on your test.